This farm is really an outdoor laboratory. This is a long-term experiment, and we've done pretty important research here on carbon sequestration, because we have different amounts of organic matter input. So we have cover crops, then we have cover crops and composts that are incorporated, and then we have some systems that receive only synthetic fertilizer, and even we have some that don't receive any fertilizer. And so that has given us, over this 19 years of this experiment, we can see it's a very sensitive indicator. The finding was that we can increase organic matter even in California, even in this climate, but we have to put a lot of organic matter in. The cover crop is definitely a benefit for the soil. The roots are still in there. So we let this cover crop now decompose a few days, and then we till everything in. So of course we see only the above ground, but there is also nitrogen in the below ground. And the roots have made channels that will help the water percolate in the soil. The one benefit that we've shown already many times is that they increase infiltration. That means water can enter the soil much more easily. So that has two functions. First of all, in the winter, in big rainstorms, the water infiltrates, goes into the ground, is stored there or recharges the groundwater. And so we have less runoff. Runoff is really not good because we're losing the water, and it also, in a big storm, it can carry a lot of soil with it, so we get soil erosion. And then if you're looking into the future, we can expect that less water will be available for agriculture because the snowpack will be less due to climate change. So we want to use water as efficiently as possible. The other function it is that it will help to infiltrate water during the irrigation season, especially with furrow irrigation. We've had plots here that never had a cover crop, and we really have a hard time to get enough water into the soil and to the plant. And then, of course, another benefit of cover crops is that they can increase soil organic matter, and some people also think it helps reduce compaction. And then they can also provide fertility with legumes. This is, for example, these legumes, they fix between 20 to up to 100 kilograms of N, depending how big, how large we let them grow. And that could replace some of our synthetic fertilizers. Cover crops are a little not so easy to manage for growers because they require tillage, etc. So we've tried different ways of managing them by terminating the cover crop relatively early. And for example, here in the background you see a triticale cover crop. If that is terminated early enough, well, it doesn't interfere with the farming operations in the spring as much. And then we're studying the below ground. We want to know how these cover crops function. So we expect that they have different kind of root systems, and so we've measured the different root systems here in these plots, and then we also installed these sensors. The sensors are buried at different depths, between 30 centimeters up to 2 meter depth, and they measure soil moisture content and soil water potential, and then some of the tubes go all the way down, and we can, at any time, we have a way to get a small sample of the soil solution and measure the nitrate in it. So we are also interested what cover crops can do in terms of preventing nitrate leaching. Okay, so in the winter, usually after a tomato crop or another high N-using crop, there is quite a bit of nitrate in the surface layer. So if we sow a cover crop like triticale, they can absorb that nitrogen, and then as the roots grow deeper, they can also absorb the nitrate down there and bring it to the surface. And then as we plow it in the spring, it will be available for the next crop. Here we are. So this is a bell bean plant, and we can see these little balls. These are the nodules, and in here we have the rhizobia that fix nitrogen for the plant. So it's a symbiosis between a plant and this bacteria, and fixing nitrogen means it can convert the nitrogen in the atmosphere. The atmosphere is full of nitrogen, but it's not available to the plant. It's not in a usable form. So these rhizobia can transform it into a plant available form. Some of the growers that we collaborate with, they use these practices regularly. Maybe not every year, but they grow cover crops because they have recognized that they benefit the soil properties, and they also put compost in because it can increase the water holding capacity of a soil. These may be small incremental benefits, but I think everything counts. And the fact that some successful growers use these practices, it tells me that there is some benefit, even if we sometimes have a hard time to actually measure what the benefit is. Farmers can follow these practices and sequester carbon, but the increase will be only over the first few years, and then the soils will have a new equilibrium, and the farmer has to keep putting in these inputs, these organic matter inputs like compost and cover crops, for example.